All right, previously on last week's episode, we talked about carbonyls. And carbonyls, we said, had this C double bond O group, and the C double bond O group would show a signal at 1700 on my infrared spectrum, and it would be a very deep peak, sometimes broad, sometimes narrow. But I said that carbonyls is just really one piece of the story, that there's actually a whole slew of families that or members of the carbonyl family that we need to pick up on. And in this video, we're going to talk about our first. And our first one is called the aldehyde. Aldehyde, the aldehyde. Now, the aldehyde functional group, again, maybe you've not seen it before. And if so, that's okay. But in the previous video, we said the carbonyl has to be here, and depending on what's on the sides, this will determine what type of molecule that I have. All right, well, finally, we get to maybe erase these things and really talk about what's on the side here. And with aldehydes, what we will discover is that on one side, we will have a carbon chain. It can be anything that it wants to be, so I'm going to put an R there. It can be a ring, it can be a straight chain, but there's a carbon chain over on that side. And on the other side is a hydrogen. So my new functional group is my C double bond O, but what makes this an aldehyde is that that C double bond O molecule is at the end, because a hydrogen is on one side of it. Okay? So, for example, if I wanted to draw a real aldehyde, what I can do is do a carbon, 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 double bond O with an H, right? That's an aldehyde functional group. Or I can draw a ring structure, and this can be a carbon, carbon, double bond O, but an H at the end. It has to have the H at the end every time, okay? Something else that some people forget about is a C double bond O, and I can have an H on each side. That's also classified as an aldehyde because I have a hydrogen at least on one side of that carbon. Okay, so those are aldehyde functional groups. C double bond O, H, meaning they happen at the end. A little bit of organic lesson for you. Now, when we talk about the infrared for an aldehyde, what we will see is a 1700 peak because it has the C double bond O that's present. So we should at least see that. But an aldehyde has something else that's very specific. And what this signal will look like is a peak that will come down, back up, and then come down again, and back up. This is the presence of the C double bond O H. That confirms that this is a carbonyl at 1700, and this is the aldehyde version because I see a double dip that happens here in the very beginning. Now, where do those double dips happen? Those numbers, again, are very important, right? So these dips will happen beside of each other. And this will always go on at around 2800 and around 2700. We call it a double peak. Sometimes you'll hear me refer to it as the bunny ears because they are literally side by side. And there's not a lot of wiggle room here. So because of that, we're just going to give you one number to go by like we did with the carbonyls. Carbonyls happen at 17, and if it's a carbonyl and you see a double dip that happens at 28 and 2700, then that is the positive identification for an aldehyde. So this one is going to happen at around 2800, and then this one will happen at around 2700. That double dip is the presence of an aldehyde. Now, if I go back and take a look at the same infrared that we ended up with last time when we talked about carbonyls, this is the aldehyde, my C double bond O H group. And because that aldehyde is present, I should be able to pick that up in the infrared. Well, here's my 1700 peak, so I know it's a carbonyl. What type of carbonyl do I have? Well, the only one that I know right now is the aldehyde. So is this thing an aldehyde? And the answer is yes, because I see a double dip that happens here, and that's around 2800, and that one's around 2700. And because those double dips are present, then I have a very good feeling that this is a aldehyde functional group. All right, so let's take a look at another example. That was acetaldehyde that we just did. So here's another one. Now, you're probably looking at this saying, oh gosh, this one's maybe a little harder to pick out. And some of them are, because some of them are a little bit busier. But if I look at this molecule down below, this is a C double bond OH, so that is an aldehyde. And I should feel good about picking out the aldehydes in the infrared. So here's my 1700 peak. That's very dominant. I know it's a carbonyl. Now I've got to figure out what type of carbonyl it is. Well, I only know aldehyde. So is this an aldehyde, yes or no? Well, I come over, and I know that aldehydes happen at around 28 and 2700. So here's 3000, there's 29, there's 28. So I'm going to come up from 28, and sure enough, I see a peak that's present. And then at 2700, I come up, and sure enough, I see a peak that is present. So that is the positive identification for an aldehyde. This double peak that happens at 27 and 2800. So yes, it's an aldehyde, and I can actually pick out those areas that prove it. All right, here's another one. This is a ring structure. This is benzaldehyde, but I see the C double bond OH group. There's my 1700 peak. I know it's a carbonyl. Is it an aldehyde? Because that's the only carbonyl I know of right now. And then I come over, and this one's a little bit cleaner to see. So at 2700, I see a peak, and at 2800, I see a peak. Both of those are present. They're side by side, and that is the positive identification for an aldehyde. Next one. Here's another one. This is cinnamaldehyde. Smells like cinnamon. Go figure. But it's an aldehyde, C double bond OH. There's the 1700 peak, so I know it's a carbonyl. And then what type of carbonyl? Well, only one I know is aldehyde. Can I pick it out? Because I know that's what this one is. And I come over, and I see at 27 and at 2800, side by side, we come up, and there is the presence of the aldehyde. Finally, my next one. This is ethyl benzaldehyde. So a ring structure with some other stuff on it. And then a C double bond OH, so I know it's an aldehyde functional group here. Well, at 1700, I see a big carbonyl band. It's right there. And what type of carbonyl is it? Well, I only know aldehydes. It's the same story, but this one maybe is a little more difficult to see. So at 2800, which is right here, I'm going to come up, and I see a small little jagged peak right there. And then at 2700, which is here, I come up, and I see a little stronger band that's right there. But I see the presence of a 27 and a 28. So that double dip is the presence of the aldehyde, right? So something that maybe I haven't mentioned yet, but hopefully by looking at the infrared, you've seen it and observed it. But these double dips, when they happen, they're about the same size, meaning that lengthwise or intensity-wise, they come down about the same position. Meaning, I don't really see one that's like a little jagged piece like this and another one that comes way down and then back up, right? That's not the presence of the aldehyde. The aldehydes are typically about the same size. They won't be perfectly matching, but they'll be on the order of magnitude that's about equivalent to each other. Okay? So that's our first carbonyl family, aldehyde. C double bond O H. In the next video, we'll talk about our next carbonyl and figure out what those will look like. Make you some index cards.